Started. Welcome everybody to today's Getting Started with Kubernetes and Rancher 2.0 training. I'm really excited to show you guys a demo of Rancher and get you started along the path with Kubernetes using Rancher 2.0. Our objectives today, we are going to be doing a bunch of demoing. We'll start off with a lot of slides, but a lot of what we'll be going over will be Q&A interactive. Please put down your questions. Start putting them in the chat as you have them, and we'll try to get to everyone before we leave. Again, this is an introduction, a technical introduction to Kubernetes using Rancher 2, and we'll try to keep to that topic. So if some of the questions are outside of that domain, we might refer you to some of our other resources like our Slack channel and our forum and our docs and our articles. But again, we will try to get to all the questions as best we can. So who are we? I'm Matthew Shear. I'm a community advocate at Rancher. My Twitter is Matthew_Shear. So you can reach me on Twitter or shoot me an email at matthew@rancher.com. And our technical demo wizard is Bill Maxwell, Principal Engineer. Thank you so much, Bill. Hey, man.
Hey.
Good morning to you.
Good morning.
Glad you're here, jumping in, hero, to help us out. And Bill's email is Cloudnautic. And Twitter is Cloudnautic, and so you can reach him there as well for further questions and conversation. So again, for this training, this is an intro to Kubernetes and Rancher, and we kind of assume you have a basic understanding of Docker concepts. And if you don't, we have a really great information on our blog, on our docs, and obviously, you can go and check out Docker as well. Here is the link to the quick start guide for Rancher 2 and future versions. So these slides will be sent out after the training. You don't have to copy down the link right now, and you will get access to it later. You also can easily access these docs from the main page of our website. Further resource, if you have additional questions, forums.rancher.com. Probably should have our Slack channel here as well. Our Slack is also really active, so both of these resources are great for additional questions and exploration to see what other people are doing with Rancher. So we're going to give some context to Kubernetes, why we built the platform that we did, and why this emphasis on Kubernetes. And at this point, I'm going to actually change the presenter, and Bill is going to take the lead here. So Bill, are you ready for me to switch screens?
Yeah, go ahead.
Okay, great. I'm going to make you the presenter.
Good. So we are. Cool. All right. So kind of with Rancher 2.0, what we've, and just in the broader container market, what we noticed was, or what's been kind of clear is Kubernetes has gained significant momentum, and the interest has grown. The market has matured a bit, and so and Kubernetes as a software platform is really gaining large adoption and interest. And so, all of the cloud providers have started offering like a Kubernetes product. I think DigitalOcean announced there's a KubeCon yesterday. So I mean, it's really, you have DigitalOcean, Amazon, your Google's, Azure. Everyone's really embracing Kubernetes, and now enterprises are installing it on their own on-premise installations and leveraging it in the cloud. If you look, just from developer interest, you can see that a lot of companies are contributing to the development of Kubernetes. With Google and Red Hat being some of the larger contributors. But one thing that we've observed is that people are deploying Kubernetes. It's there's a lot of there's some challenges in how to integrate it into your environment and really leverage it as quickly as possible. And so being able to plug it into your authentication systems, being able to log and monitor, and just be able to see, gain insights into how your workloads are doing. There's just a lot to take in, and there's certainly a lot of hooks, but just sort of understanding and going through that exercise is a bit challenging. And so, the other part of it too is that Kubernetes is moving at a fast clip. They're adding new releases or minor releases are coming out with every 3 months or so, which is pretty fast. And a lot of new features and ideas are coming into play, and things are stabilizing, and it's just being able to keep up with that and upgrading. It presents an interesting set of challenges. There is no LTS version, so everything is sort of moving along. You got to kind of keep up with these minor releases as best you can. And part of the other thing too is, as such a powerful and flexible engine as Kubernetes is, there's a lot of little abstractions and nuances to using it. So, being able to go from kind of the Docker run command straight to Kubernetes, it requires a bit of learning and some new concepts to familiarize yourself with, which is a bit challenging, and sort of the way that some of that gets broken down. Again, it's extremely powerful, but just lots to sort of make sure you know and understand. And so kind of with Rancher and Kubernetes, Rancher sort of sees this, as sort of bringing kind of the easy to use interface to Kubernetes. And then, one of the things that we've observed over the last, as we've been running Kubernetes and our previous versions of the product, is people end up with multiple clusters, and sort of being able to keep those consistent and have a tool and infrastructure in place to sort of keep that, your access controls and your policies between clusters consistent, is a real challenge for folks. So, by putting in Rancher on top of it, you can leverage all of the orchestration capabilities of Kubernetes, but adding, the ability to log and monitor, and create RBAC policy that is replicated in access controls that across your clusters that really help out. Because you can get kind of this Kubernetes, in the broader market now, you're able to get Kubernetes from just about anywhere, whether you choose to run it yourself or use a distribution like Ubuntu's or CoreOS's, or get it hosted from a cloud provider like Amazon or Google or Azure. It's coming from all these different places, or and being able to sort of manage and wrangle that and not lock yourself into any single provider, really is a good place for Rancher 2.0 to come in and help. And then also helping you, consume that those Kubernetes clusters as quickly as possible through kind of an easy to use interface, being able to monitor and capture your logs, and get up and running with your CI pipelines quickly. And so, looking at Rancher 2, if you're familiar with Rancher 1.6, we had a traditional infrastructure where we had our own separate app servers and a MySQL database. And sort of now in 2.0, we've moved over to actually leveraging Kubernetes ourselves, to deploy and run Rancher, as a highly available application within a Kubernetes cluster. So we use etcd now instead of MySQL. All of our components are deployed on top of Kubernetes and leverage the extension points within Kubernetes to deploy and manage Rancher. And so we're handling authentication for you and tying that into your existing authentication backends, and then forwarding requests down to clusters for you, so that you get this centralized RBAC and access control mechanism. Before we get too deep into the demo, though, we're going to go over some basic Kubernetes concepts. We'll look at pods, deployment, services, config maps, and ingresses. All right. So Kubernetes, the smallest unit is a pod. Coming from the Docker world, you're sort of mostly familiar with containers. Kubernetes uses pods, which in most cases one could think of them as almost one for one, but really pods are like a group of containers that are working together, and they all share kind of a same unique IP, and they can all communicate with each other over localhost. And so a lot of times you can deploy multiple containers to work really well together. But again, in a lot of cases, most folks still run. You can sort of think of that one container, one pod kind of mapping. Yeah, and we just sort of kind of talk to that a little bit. And so,
Hey, Bill, can I interrupt
yeah.
you for 1 second? Because there's a quick question here that might be relevant at this point, which is from Christoph, and he asks, is it still possible to run Rancher 2 on Rancher OS? And if so, will it run in the Rancher OS Docker or on the K8s cluster?
So yes, you can still run Rancher 2 on Rancher OS. You can run the straight Docker command, and you'll get a single node server running as a Rancher 2 server on a Rancher OS VM. The HA story for Rancher 2 is to deploy it into a Kubernetes cluster. And so with that, you would use RKE to deploy on top of Rancher OS Kubernetes, and then deploy Rancher OS or Rancher Server 2 or Rancher 2.0 into that Kubernetes cluster on Rancher OS. So still possible. I think there's a couple of things that it can be done. There's a couple of things we're doing with RKE to streamline that process on Rancher OS to make it even easier and simpler.
Awesome, thank you, sir. No other questions at this point.
Okay. Yeah, so the next concept is replication controllers and replication sets. Sort of Kubernetes, everything sort of breaks down. If you say you want to run a number of pods, like you want to run 5 pods, you have either a replica set or a replication controller sort of basically managing that state, the size of that, that number of pods at any given time. And so there's a specific set that's dedicated to just ensuring this scale of a particular set of pods. And so building on top of that, deployments allow you to define the pod definition plus the number of sets or number of pods you want running at any given time, and the deployments sort of go out and create the deployment and then create the replica set, which then creates the pods. And so it's sort of managing that concept all in kind of one unit. And it also allows you to do rolling updates and rollbacks and keeps versions of the pod definitions. So the deployment's a really useful concept, and is probably the one you'll interact with the most when deploying applications. And so then Kubernetes has the concept of a service, which defines the DNS entries and gives you a consistent IP for a set of pods. And so there's a few different types. It also it defines one of the ways to expose services outside of the Kubernetes cluster. So if you want to have a node port that exposes those endpoints at the node level, there's cluster IP, which is the within a cluster address. There's a load balancer, which will actually create a load balancing instance provided by the cloud provider. So in Amazon, I can fire up an ELB or in, for instance. And then there's, yeah, those are the 4. I think there's also an external type, or headless, which basically allows you to sort of define external services. The other thing that Kubernetes builds in is the concept of a config map. So this gives you a key value data store to provide values for your containers that can be consumed either as environment variables or as files in a volume, which is really, really nice and convenient. So for instance, you can create the key value could be, my Nginx config, and you could dump that straight into, that's the Nginx if you want, which is nice because then the configuration is now outside of the pod definition. Well, yeah, the values are stored outside the pod definition. And then the other way to expose traffic to services outside of Kubernetes, or expose services outside of Kubernetes is through ingresses. These are layer 7 rules typically, so you're routing on URI paths or hosts or ports, and so these expose all of these allow you to expose your services outside the cluster. And so today with Rancher 2, we're going to go over setting up Rancher itself, the different options there, go over the concepts of clusters, auth, storage, projects, namespaces, catalogs, and the CLI interfaces. Yeah, so let's jump into that. Were there any questions?
No questions, sir. Let's do it.
All right. So here's the new docs page for Rancher 2. And to get started and set up, you can follow the quick start guide. We have installation instructions for the servers. There's the single node install and then the high availability install. I've done, for this demo, I'm running a single node install, which is just to make sure you've got the minimum requirements and just a simple Docker run command and exposing now on port 80 and 443. Excuse me. But to do an HA install, just to touch on that quickly, you're going to start with 3 Rancher servers, or sorry, 3 servers, and then use RKE command, which can be got from GitHub. You use that binary. There's some YAML templates that outline the different scenarios. Still sticking with the minimum host requirements. These networking ports will need to be available. But once you have RKE, you provision the cluster, you edit the YAML file and set up your certs. There's a couple of different methods, either using real certs, self-signed certs, or just the internal certs that the Rancher server can generate on the fly for you. And then you'll bring it up and you'll have a HA Rancher set up. When that RKE cluster comes up, Rancher server will be deployed into it. All right, and once you've done that, one of the first things that'll come up is it'll prompt you for the admin password and just to set the external server URL. But then typically that allows you to use the internal local auth, but most users want to either use Active Directory or like a GitHub auth. And so to set that up, we've kind of brought back our wizard from previous experience. So register that. now we'll enable off. And so there's 3 different modes now that we can sort of operate in. We can allow any valid user, so anyone that could log into GitHub could then log into this cluster, this Rancher control plane. Allow members of clusters from authorized users and organizations. So you can authorize like an org and specific users to come in, or just restrict it to only these authorized users. And you set the authorized users here. So then save. And so what we've done here is configured authentication for Rancher itself. The other thing that we sort of provide, and then when you come here now, you'll see that we have users, and we can assign different roles to them. So there's the standard user, administrator, and custom. And so custom ties back into more of, we're able to leverage all of the Kubernetes RBAC that's built in. And so here you can create kind of custom roles and demo role. And in the context of either everything, a project, or a cluster, I can grant resources, access to specific resources. Say, this person can list and get, basically read only on ingresses, or I could inherit from another role. But here we give you kind of an easy way to pick out the different resources and create the underlying Kubernetes roles, and then you can actually bind them to users here. Cool. So that's just sort of setting up the initial thing on authentication and some roles, and this gives you really fine-grained control. Just to touch on it really quickly while we're here is pod security policy. It's a security feature inside of Kubernetes. And this allows you to prevent containers from running in privilege mode or doing host bind mounts, and it gives you a lot of flexibility at a container level on how to restrict things. And so you can create these policies and manage them here, and they'll also be able to be consumed in your different clusters. So the next thing, once you've got users and everything configured, the next thing you'll do is add clusters. And so here what we can do is we can add a live demo. I'm going to use DigitalOcean. We can set different cluster options. So under the hood, we're using RKE, but I can select the Kubernetes version. I can select the network provider. If we define a pod security policy, I can enable it here. If we can require, or either we require supported Docker versions or allow you to run newer versions. And then different cloud providers can be enabled as well. So here I'm going to do Bill live demo. I'm going to create a 3-node cluster. I'm going to use a node template. So these templates allow you, or specifying basically server config for the different droplets. I've already gone through and created a template. And so I'm going to deploy a 3-node Kubernetes cluster in DigitalOcean.
Hey, Bill, while you're doing that, there is a question from Finakaran, I'm probably butchering your name, my apologies, about importing and managing self-hosted Kubernetes clusters with RHEL 7.4. And so maybe you could cover importing custom clusters too.
Yeah.
after.
Yep. So while that's provisioning, you have different options. We can reach out. You can add clusters from different sources. So we can reach out to the different cloud providers like Google, Amazon, Azure, and provision an instance of their hosted Kubernetes solution and then import that back into Rancher. We can also provision VMs on EC2, Azure, and DigitalOcean, and vSphere. And we'll go out and provision VMs on those cloud providers and install using our KE, we'll install Kubernetes on top of those VMs for you. There's also this custom mode, which will give you Docker commands similar to what we did in 1.6 that allow you to run a Docker run command, which will register the node back in as part of your own normal provisioning process and add it to the cluster. And then there's import. And so if you've got a KOps cluster or a kubespray cluster or something you just provision with kubadmin, however you're managing that, you'll still continue to manage it with that, but then as far as the provisioning of Kubernetes. But you can run this demo. You can create that, and then we give you a kube control command to run, which you can then import that, which will then register that cluster back into Rancher, and Rancher can start managing that cluster, from the RBAC and roles perspective. But those are the different ways that you can currently bring a cluster into Rancher. We do have in order to provision the nodes, we're still using Docker machine node drivers under the hood. And so there's a few extras that are not enabled by default that can be enabled under this nodes tab at the global level. And so you can see here, this is starting to provision. And so as that's coming up, I can show you the pre-demo cluster. So I built a little one node cluster before the webinar. You can quickly get into it once it's imported. You can quickly get into it and run quick kube control commands, or you can leverage kube config files provided by Rancher. You'll see that we'll route that through Rancher and it'll handle the authentication and then send that down to the clusters as they need to be. So you'll use these kube config files for your individual users. Here you can manage who the different members of this cluster are. You can add additional ones from the user pool. Projects and namespaces. So Kubernetes has the concept of a namespace, which just is like a unit of a partitioning unit within a Kubernetes cluster. And so you can do, you can assign a user, access to a specific namespace, or you can assign resources to the namespace, as far as CPU and memory consumption. That can all be applied kind of at the namespace level. And so Rancher has also added the next a layer on top of that called projects, which is really a collection of these namespaces. And so if you want to deploy, a team can deploy applications into different namespaces, but they all, sort of work on that same general application within a project. Also at the cluster level, as an admin, you can provision the different storage classes. You can see we've got default, and whichever, whatever you're running. And you can provide custom ones if you've got, different binaries, and add parameters and customize. But this allows you to define storage classes for the cluster. And you can see a node view at the cluster level of all the hosts that are in there. And then a high-level dashboard. So jumping into the default project. Before we do that, let's take a quick look here at the tool section. So in Rancher, we've added a few things. So we have built in the Prometheus alert manager. And so you can configure different notification endpoints, Slack, email, PagerDuty, or just a webhook, so that you can receive alerts based on events that are happening inside your Rancher cluster. And here we allow you to define alerts. So you can say, testing, when running a resource, this deployment, node, like if a node drops below or is using over 70% of its CPU, send a warning, and then you can pick the notifier from here. And it'll just, if that condition happens, then you'll get an alert that says, this is happening. The other thing that we've added is log collection. So we're really focused on being able to collect logs in allowing users to route them. Most enterprises that we've seen have some sort of log collection in place. So we've made it really easy to basically grab the logs from the cluster and send it to that location. And when you set it here and define it at the cluster level, what we're saying, all logs in the entire cluster will go to that single location. And so if you're an operations team or a security team or someone, basically, no one at a project level can override where these logs are going. They will always come, all cluster logs will always go to that. Yeah, and so we've had these different backends, and through these, you should be able to integrate with most existing solutions. Pipelines. So I can enable a pipeline. So we've built in a simple CI system into Rancher 2, and at a cluster level, you need to enable it so that it gets deployed and users can then start consuming it in their projects. So at the project level now, you can see I've got this main workloads tab, which allows us to quickly deploy and demo up, Nginx. You can select different types of workloads. So if you want to deploy 3 of these pods, or one pod, a daemon set, or one of these on every node, stateful sets, cron, or just a regular job. You pick your namespace. You can create a new one on the fly, expose certain ports, then quickly launch that. The nice thing is now we've got a way to sort of export the YAML file. You can do it. But you can download the YAML that was used that ultimately ended up getting deployed. Once you've deployed a service, you can then app default namespace, and we're going to point this at my demo app workload on port 80. And so now, in a moment, once that's all deployed and running, see that now, and then start digging into each of these. So you can expose this, generate automatically. So now it will go to my Nginx and it'll give us a built-in xip.io link for that. Here we can add just regular services. And any one of these, if you've already got YAML, you can import that. You can add volumes. The other one to look at is pipelines. And so since I enabled it at the cluster level, I am now able to add this at a project level. Can build on tags, PRs, different events, cron. I'm only going to build the master branch. And then here we can say this is going to be my demo. Edit this so that it just runs the script in Go. And we have build script already. Save. You can publish the image up to Docker Hub. I'm not going to do that right now, but I can add that and then manually trigger a build here. Sort of while that's going and building, I'll show you the new Rancher catalog. So here at the global level, you can specify specific catalogs. There's Helm Stable, Helm Incubator, and then Rancher is curating a library version of some popular apps, or you can add your own catalogs. That is still possible. So back here, that's where these catalogs come from. See how that's going. Yeah, it's still running. But here on the catalog app, so I can launch one. And here what we've done is we're able to prompt the user for, under the hood, these are all still Helm charts. And so you still have kind of the access to the Helm configuration under the, you can still just use it as a Helm chart, but we've added kind of a simplified question and answer section to make this easier to consume for users, and asked for the different types and different configuration values, sort of giving you, trying to present the most commonly used questions that one would configure kind of right away. And so under the hood, we've got this answers YAML, and we've got the questions. There we go. Yeah. So there's a YAML, an additional YAML file in the curated templates that we're doing that define these questions with different conditionals, so that if you choose true, then you see different options and configure things. So if you're not using persistent storage, there's no need to really define it. So we can adapt based on what we do suggest. Yeah, so we can deploy one of these. Quick Redis one. Launch, and so here we'll launch out a Redis cluster, and you can also see it here in the workloads. You can see what's the namespace Redis was created. There's different containers getting launched to provide that. Yep. And so then at a project level, you can also configure logging. So this will be in addition to whatever is being logged at the cluster level. We'll also be logging at the project level. And so if the development team doesn't have access to the security team or operations teams logging infrastructure, they could stand up something on their own and get their own logs that way. They can configure that here. We do support private registries, so here you can add different registries or private registries and specify a scope to what they're available to, like a single namespace within a project or every namespace in that project, so you get some fine-grained control over where those things are. You can configure alerts at a project level. You can upload your certificates that can then be consumed in your ingresses later on. So when you can add a certificate and put the private and certificate files here, making sure to keep the chain intact. And again, also specifying where that will go. Secrets, this is all leveraging Kubernetes secrets behind the scenes, but you can add your secrets. And then config maps, you can add new ones and key value pairs, and just keep adding additional pairs into that. Yeah. So just checking back on our pipeline, see if it's had a chance to run. This is just running against a single. The cluster powering that is just a little single 2-core small VM, and I'm asking a lot of it. Yeah, let's take a look at this live demo. Yeah, so that pre-one kind of crashed out. But here, we've got our live demo cluster, and you can see that this one actually has the 3 nodes, and they're all 2 gig VMs. Which version of Docker was installed, Kubernetes version. Yeah, and you can see that this one is unique from the other. And then here, you can generate the kube control file. Launch kube control. You can see that this one is a different node and can run against that. So I think that's kind of Rancher 2 in a nutshell. Yeah, let's take a look and see what questions we got.
Amazing. Thanks, Bill. You went through that from top to bottom, so impressed. Okay, let's start going through questions. So the first is from Paolo. Is it possible to import Kubernetes clusters plus 1.8?
Yeah, so Rancher 2 supports one Kubernetes cluster, or Kubernetes 1.8, 1.9, and 1.10 right now. Yep.
Awesome. Easy question. Now from Thinacaron, he asks, this is kind of a follow-up to that question about self-hosted Kubernetes clusters. On self-hosted Kubernetes clusters, how do you make Rancher 2.0 itself fault tolerant? What if Rancher 2 control plane dies? Maybe a dumb question. Are there projects like Bootkube, etc.?
So yeah, so Rancher itself as a control plane, the way that we sort of see the architecture going is that you'll have a standalone Kubernetes cluster of about 3 nodes running RKE, running Rancher server. That cluster with 3 nodes has a highly available etcd cluster at that point. There's a backup strategy being built into Rancher that will they'll basically do etcd backups to like a persistent, like an NFS share or something like that sort of exists outside those 3 nodes. The components themselves running in Kubernetes, Kubernetes is highly available. So if a component, and it's also designed to run services that are highly available. So if one of the Rancher components crashes, Kubernetes should start that component back up. And that's sort of being the motivation behind that. Each of the other clusters that are imported into Rancher 2 are essentially, they're standalone. They have their own etcd, their own API servers, and Rancher 2 is really interacting with them over that API interface. So in the event that the Rancher 2 server installation goes down, the user-generated kubeconfig files, like the files that are generated here on this page, wouldn't work, but the administrative kube control files that were generated as part of your installs or your cloud provider kubeconfig files would still work. So in a pinch, you still have it, that method of interacting directly with the cluster using those other methods. So the way that Rancher is working is everything, like all of the access controls in RBAC are being, they're actually creating real Kubernetes objects behind the scenes in each of these clusters. So all the service accounts that were created and using the roles that were created by Rancher will continue to still be enforcing, and still be consumable. Basically, Kubernetes will still be enforcing those. It's just that Rancher can't make any changes while it's down. But it's still the local Kubernetes cluster acting, doing its thing at that level. Hopefully that clarifies it.
Awesome, thank you. Okay, we have another question, and this is a bit of a troubleshooting question, so it might not be, we might not be able to handle it through this training. This is from B Bond. It says, we're getting an error. Let's see, we're getting an error. Oh, it's separated over 4 different questions, so I'm trying to piece this together here. It looks like has a Kubernetes cluster error, and the error is, this cluster is currently provisioning. Areas that interact directly with it will not be available until the API is ready.
Yeah, that just means we're waiting for Kubernetes to come up before we can interact with that API server.
Okay, cool.
Yeah, and so until that API server comes up, we can't really communicate with it.
Is there any reason why that would be delayed?
It takes a few moments to download all of the images and get up and running. The logs from that message, basically, once that Docker run command will start a bunch of other Docker containers, and so on that, you kind of have to look at the logs of the different containers that are trying to come up. I know on RHEL hosts that do have SE Linux enforcing, there's some other special things to take a look at. On the GitHub Rancher RKE README at the bottom under Project Atomic, those are the same, whether you're running Atomic or RHEL, the commands seem to be the same, but you need to update that you basically need to allow access for certain components to run. But that you can find that on the RKE README.
Awesome. Okay, great. Yeah, he says he deployed as a Docker on RHEL. So I guess refer to the what did you say to refer to again?
The RKE README,
RKE.
GitHub/Rancher/RKE. At the bottom of the README, there's a Project Atomic section, but it applies to all RHEL systems with SE Linux pretty much.
Perfect. Okay, awesome. Great. So 2 more questions. This is from Gary. Are you able to send node and container metrics such as CPU, memory, etc., to Elasticsearch, or do you have to use another tool like Prometheus to see this information?
We don't have it built in or exposed at the Rancher level yet. We do have plans to add Prometheus metrics, like collection, so that you can view it. within Rancher, but we haven't got that far yet for doing all of the metrics collection. But again, this is Kubernetes, and while not through the UI, we can still, if you run with RKE at the command line, you can pass different options to kubelet and the API servers, and basically turning on all the metrics collection endpoints, and you should be able to get at the logs. There's also a Helm chart for Prometheus that I know some folks have used as well.
Awesome. Okay, cool. A couple more. Christoph asks, how do you handle Kubernetes upgrades?
So from the Rancher 2.0 UI, it's not really available yet, but from the Rancher RKE CLI, which ultimately uses the same code under the hood, you swap out the images, and RKE is able to go through and upgrade the different components as part of like a re-up against it. And so it'll upgrade etcd the different Kubernetes components, and they'll all be running. It just moves them from one version to the next. So
Awesome.
yeah, we just upgrade all the images.
Awesome. Okay. Thank you. So the next one, last one that is posted is from Tim, who says, how would we set up a dev test production environment in Rancher? Would we use project namespaces for each environment? What would you recommend?
That really depends on the level of isolation that you want to have between your dev test and production environments. Production, typically you want that as isolated from accidents as much as possible. So typically we see a lot of users run production on its own Kubernetes cluster. You can have multiple teams sharing that production environment through projects and namespaces, but basically everyone treats that as a production system. And by doing that on its own hardware and not sharing it with test, you don't have someone accidentally running a load test against test, which impacts the hosts that are running production inadvertently. So it's just to avoid things like that. You could get away with like a dev and test set of environments on the same in the same Kubernetes cluster on the same set of hardware using projects and namespaces that way. Or you could separate those all out into their own individual clusters. It really is up to you.
Awesome. Okay, well, that was all the questions that have been asked. So I think we will wrap up since we're right near an hour anyway. Is there anything else you want to add, Bill, before I take back?
No, not today.
Okay, awesome. Well, thanks everybody. This has been super, super informative and helpful. Really glad we could provide this training and that the questions, help us improve and know what we're doing right and what to get better. Bill, I'm gonna take back the presentation.
Okay.
All right, so just a couple more resources for everyone. The slack.rancher.io, the Slack channel, the Kubernetes channel is a great follow-up, another place to post additional questions, offer advice and have some community around these tools and this topic. Want to thank everyone again for being on today. To find out more about Kubernetes and Rancher, go to rancher.com/Kubernetes. You can see a little bit more information about what we do with Kubernetes and Rancher, and you can also use the Twitter hashtag RancherK8 to follow up about the training. How was it? Let us know, what worked for you, what we could do better. Kind of leave us testimonial would be amazing. And then finally, one other offer is our deploying and scaling Kubernetes with Rancher guide. It's pretty massive, 60 pages, and so that is another deep dive that you can do after this training if you want to go further. And just reiterating, we will post this training, the recording, and the slides online on YouTube and SlideShare respectively, and also everyone who registered will get the links to that in their email, hopefully in the next 24 hours. That's our aim. So with that being said, that's all we've got. Everyone have a great day, and thanks for joining the call.